Hello, this is Yelin, and I will explain the homework 9 problem 1. We are given that suppose WT is the winner process discussed in class. Now let us define xt equals to W of t plus 1 minus WT. So we need to find we need first question is we need to draw a couple of samples of x of t. First, we need to know that w of t equals to this this equation, and it is a normal distribution with expected value equals to 0 and standard deviation is 1. So one sample of xt could be like this, I think, because it's just because xt is a normal distribution, so it means that it's not involved by t. So it just has more probability that xt equals in this area, I think. So it will be some curve like this. The second question is to find xt, the expected value of xt, and autocorrelation, and its autocorrelation. Because xt equals to is a two Warner process minus each winner process expected value equals to 0. So the result of this two is equals to 0. And we also need to find the autocorrelation. The definition is like this, and we rewrite it. Then finally we got something like this. And we already know that the winner process autocorrelation function is in this form: minus t1 t2 times alpha. Alpha is a we derive it from the random walk, and y of t is a random walk. So we define s squared divided by t when n and t like this, and it's equals to alpha. So we just move on and discussion the different condition. When t2 minus t1 greater than 0 less than 1, so the result could be right like this. And when t2 minus t1 greater than minus 1 less than 0, and the result is like this. When t2 minus t1 greater than 1, so the result is 0. And t2 minus t1 less than minus 1, the result is also 0. From the result we derivable, we know that the expected value of x of t is some constant is equals to 0, and the autocorrelation function is a function of the time difference. So x of t is y since stationary. And the other thing that I don't explain because I don't understand. And problem 2, we're given that that n be a Poisson process with parameter lambda, and we define that a new stochastic process as x of t. And from the lecture note, we observe that x of t is just is very similar to the semi-random telegraph process. So we just use a method, and we draw the one sample is t and is x of t. And first we need to find when xt equals to 1, the probability of x of t equals to 1. So is the probability in time range 0 to t and is odd, is equals to, because we know that x of t, because we know that n is a Poisson process, so we just write it e minus lambda t and times lambda t plus blah blah blah, and this part is a sich lambda t. And question C, we need to find the expected value of xt. And because there's only two outcome, 1 and -1, so the probability of xt equals to -1 is just 1 minus xt equals to 1. So it's 2 times the probability of xt equals to 1 minus 1, so is minus e of e raised to minus 2 times lambda times t. And D is we need to find the autocorrelation function. So by the definition, it's like this: when t1 greater than or equal to t2, the autocorrelation function could be right like this, and we gave the result is minus e raised to minus 2 times lambda times t1 minus t2. Similarly, and we got the result of t1 less than t2, so it's minus minus e times raised to minus 2 times lambda times t2 minus t1. Therefore, the autocorrelation could be right like minus t minus e raised to minus 2 times lambda times the absolute value of t1 minus t2. From the we could use the result above. We know that the expected value of xt is minus e raised to 2 minus 2 times lambda times t. It's not a constant, so we could conclude that this x of t is not y since stationary. Thank you, that's it.